the host for today. Without this, the conference, of course, wouldn't be happening, so thanks for that. Very brief introduction about myself. So my name is Sven, and I'm the technical director for WithSecure in Singapore. So we're specializing in penetration testing, red teaming, offensive security engagements. And I'm living now in Singapore already for 8 years. Originally, I'm actually coming from Germany. So I'm not non-English native speaker. Oh my God, now I mixed up the words, whatever. I'm doing pen testing already for quite some time. So for roughly 12 years, I'm in cybersecurity. The majority of the time I was doing pen testing, of course, a lot of application security, mobile pen testing, everything around it. I was also working as a security architect for a while, and in general, try to advocate also for application security, which I'm also doing as part of the OWASP Mobile Security Testing Guide project, where I'm one of the project leads already since 2016. So the agenda for today is how we can scan for secrets in your code base, meaning in a GitHub repository we will be focusing on today, how you can trigger SAST scans, meaning static application security testing, and also doing software composition analysis. On the right side, you can see a picture of a so-called cannonball tree that's quite common in Singapore and that we see quite often when I walk some trails in Singapore. And you can see that the fruits are hanging quite low, and this is what we will be doing today. We're trying to collect the low-hanging fruits just in this time, the vulnerabilities that you might be seeing, or the easily identifiable vulnerabilities in source code and in iOS apps. So let's start first with secret scanning. First question is, of course, what are secrets? So I'm not talking now about personal identifiable information or anything that is related now to a user. Secrets is really about encryption keys that might be used. I mean, things need to be encrypted, as we also just heard in the talk from Helen. There needs to be encryption, and we need to protect these kind of secrets properly. So there might be symmetric encryption, so you need to store the symmetric key, of course. If you have asymmetric encryption, you need to store the private key properly. There might be API tokens, there might be certificates because of mutual TLS, MTLS, and of course credentials. So there are a lot of things that one might need to use, or the developers might need to use, and that they need to secure properly. So to give you a few examples of what can go wrong, and this is just a summary of also one of the trainings that I'm doing with developers when we're doing a little bit of threat modeling. So these are just some examples of what can go wrong when developing a mobile app or also an iOS app. So for example, if there's a production build of the iOS app or Android app and it's available in the Play Store or App Store, then an attacker is of course able to decompile an Android app or disassemble an iOS app, and then there might be secrets in it, right? Then also in the pipeline itself, in the CI/CD pipeline, there will be secrets because the pipeline might be talking to some software as a service that is doing some scanning. There's a lot of integration. So this means there will be a lot of secrets in the pipeline also. The question is, are they protected properly? Secrets can be committed to the GitHub repo, of course, by the developer. And secrets might be on the workstation of the developer. And secrets can even be in third-party SDKs. I mean, we're relying a lot on libraries, a lot on SDKs, and we do not really know if the secrets are actually properly handled. So we will be focusing on this threat because the developer will potentially upload some secrets into the repo. And the thing is, this is a snippet of the GitHub documentation. And here it also says, if your project communicates with an external service, you might use a token or private key for authentication. Obviously, this is what apps are supposed to do, right? There will be a lot of integration with other services, and therefore you need to authenticate. The question is just where's this information then being stored? And also in the last sentence, you can see that GitHub is, of course, suggesting to put it into proper secure storage. So the thing is, if secrets end up in a repository, then this is also a huge attack surface. And this is usually a very easy way also to get in. If somebody's trying to attack a company, then they might just go through the public repositories, and there might already be a lot of attack surface. So if secrets are now available in a repository, there are tools available like Trufflehawk, and there are many other tools that are being used by pen testers to simply scan the repository for secrets. And if a developer is simply committing a secret into the repository, then realizes, oops, I shouldn't have done that, is just committing again, is overwriting the secret so that it's gone, it will still be there, right? Because it's in the Git history. So, and these kind of tools like Trufflehawk will simply scan the whole history itself. And the same is for private repos. If you have a breach or some attackers actually able to access a private repo, then also the first thing that they will be doing is scanning the complete Git history for secrets. There's of course research ongoing, and we hear it in the news almost daily for years. And these are just two examples. Somebody in a hospital was uploading, for whatever reason, an Excel sheet to a public Git repo. Ouch. So 16 million records of people in Brazil were therefore exposed, and all these kind of things are happening. Of course, even worse if it's a real secret. In this case, the signing key, the private key of an Android app from Facebook, not the Facebook app, but one of the apps that Facebook is producing, the secret key was being exposed, which is a worst case scenario because this means that everybody who has access to that private key is then able to sign this app and then also upload it to the Google Play Store and can just put in malicious code, malware, whatever. You upload it, it will automatically be installed on any device that has this app. So this can have really, really bad consequences. So secret scanning itself, there will always be some kind of false positives, because how secret scanning works is you have some regular expression that is just trying to identify specific keys, for example, an API token for Slack or for AWS or whatever it might be. And it's always checking for specific entropy then, and there can, of course, be false positives. So therefore, you need to tweak it, of course, to your environment. And these kind of scans, like secret scanning, should be happening as early as possible, because you do not even want that this commit is actually being happening when there's a secret part of the commit. So therefore, you should do the scan already as a so-called pre-commit hook before the commit is ending in your repo. And then, of course, during the build in the pipeline, the scan should also happen. Just that we're on the same page. Also took me a while always to understand it, and sometimes I mixed it up. So false positives, that we're all on the same page, just means that there's an incorrectly flagged security vulnerability. So your tool is showing you something that is supposed to be a security vulnerability, but it isn't. This picture might also help to clarify it a bit further. False negatives simply means that we have a vulnerability in our code base, but the tool is not able to pick it up. So therefore, we have false positives and false negatives. And for tooling, it's really always to find a sweet spot between these, because you do not want to be overwhelmed with false positives, and you also do not want to miss any false negatives. So that's always where a lot of tweaking might also be needed, and what is really then the art of the security engineers or the developers to find the right way of having the right amount of information that a tool is then generating. So we will be focusing now on Git leaks. So Git leaks is a secret scanning tool and is able to identify a lot of secrets out of the box. So there are a lot of different regular expressions that are already shipped with Git leaks that can really help in order to identify secrets easily. You can also add your own regex and rules to it, so it's very flexible in terms of configuring it. And what I was talking about earlier in terms of the pre-commit hooks, this is an example of how this works. So you can see here my Visual Studio Code. I have a pre-commit configured, a pre-commit hook for Git leaks. And I'm generating now a secure shell key pair in this project, meaning there will now be a private key and also a public key. You can see it's popping up on the left side. And now I want to simply commit to my project. So I'm adding this now, give it a name. I'm just have done something. I want to add now the changes into my repo. And you can see there's an error now happening in my Visual Studio Code, because this pre-commit hook was triggering this Git leak scan and was not allowing me to actually do this commit into the repo, which is great, because this is exactly this shifting left that you might have heard, because this means that the developer will get very early in the SDLC already an error saying, please look at this, there's a private key here, please get rid of it. and only then you are allowed to actually commit into the repo. What we will be looking into now is GitHub Actions. So GitHub Actions is part of every GitHub repo, regardless if you have now a paid account or free account. GitHub Actions is there, and GitHub Actions is basically a CI/CD platform that is already integrated into the GitHub environment. And in the picture that you can see here, there is an event on the left side, and an event can be a commit, can be a pull request, and this event is then triggering a GitHub action if the GitHub action is defined to be invoked from a commit or pull request. And this GitHub action has then a job. A job can be, we are scanning now with Git leaks, and this job is being executed then on a runner. A runner is a virtual machine that is part of the GitHub environment where this GitHub action is then being executed. And these kind of workflows you can then create in GitHub through GitHub Actions to deploy your app, to test your app, to build your app. So you can do a lot of things with GitHub Actions. It's really very flexible because it's just a YAML file that you need to create. So it's also quite easy to understand. There's not much programming involved because it's basically a text file. And what we will be doing is we will be doing a GitHub action with Git leaks. There's a marketplace on GitHub where you can browse a lot of different of these kind of actions. And in order to integrate them into your GitHub project, you just need a few lines of code that you can see here on the right side. So you just put this into your YAML file, and then the GitHub action is already being triggered. So let me just give you a quick demo for this. Okay, that was of course not working as it should be. Okay, so what you can see here is a GitHub repo, and here is the GitHub workflow. So in this directory, there are now my predefined workflows, and we want to do now Git leaks. And if you're not aware of it, I just want to share with you, if you are in GitHub here and you just press dot, then the Visual Studio Code will open. I just explored this a few weeks earlier when a friend of mine was showing this to me, which is pretty amazing. So you have your web, your Visual Studio Code in the web editor here. So now I have this predefined workflow. I just uncommented it now. I do not want to go into all the details, but the main thing is that we are using this Git leaks plugin. There's a few more things in terms of configuration, but what we will be doing now is we are simply committing this now. And oops, put this here. Then it should already be done. We go back to our repository. And now I already made a commit because I uncommented this GitHub action file. I mean, usually, of course, a developer would be doing some changes to the source code. So now we can go to Actions. And you can see that we triggered now something. There's already another workflow running that I activated. But this is the one that we want to look at. So there's now this test, the commit that we did, and it triggered this Git leaks action. So this is now running. And you can see that quite a lot of things were happening here now, and there's something happening here, and it's red, and there's an error. What this means is that Git leaks found now a few things that are not okay in this repository, because might be false positives, might be actual findings, but the cool thing is that this whole check was now being done automatically. So whenever a developer is now committing something or is making a pull request, this GitHub action is being executed, and it will be flagged out. The thing is, there are a lot of tools that can do the scanning, but that's of course only half of the solution, because the main problem is usually that you get a lot of nice vulnerabilities, maybe not vulnerabilities, because you still need to triage them. The other part is about the managing of it, right? Because it doesn't really help if you get now hundreds and thousands of vulnerabilities, but you have no effective way of managing all of these vulnerabilities, especially when you want to do deduplication, when you want to get rid of false positives permanently. And the cool part in GitHub is that, let me make this also a bit bigger, you have the security here, security tab, and then you see here code scanning alerts. And you can see here that automatically, when the Git leaks action was executed, the findings were actually being pushed now into this here. So we have the findings already available here. We only activated the Git leaks action, and everything, the scanning was done, it was being pushed in here, and then we can do some triage. So we can go here into this finding, we can directly create an issue out of it, or we can simply say that this is a false positive, and then it's gone and it simply vanishes. So this is a really amazing feature. So let me go back to my slide. So how this was working is that Git leaks was creating a so-called SARIF file, which is a JSON structure. And this is a new file format. I mean, it's already out there for a bit, but the thing is more and more tools are using it as an output format. And this is a common, or this is a format that is specifying how a vulnerability is being described. Because the problem is that we are facing at the moment is that every security tool, they have some output, XML, JSON, everybody, the JSON might be looking different, maybe there might be PDFs, but there's something machine readable, but it doesn't really help because it's not a common format. So SARIF is trying to address this problem. It's supported by Microsoft, it's available in GitHub, and a lot of open source tools are using this now as an additional output format. And if you have the SARIF file, you can directly ingest it into GitHub. And then it's available in this security tab that I just showed you. So therefore, you can have an end-to-end flow that is based on the SARIF output, which is really fantastic. So what do you need to do if sensitive information was identified? I mean, if you run the scan the first time, I guess there's no need to panic because the secret might be there already for quite some time. So it's just about really letting everybody know who's involved that that there's a secret exposed, and that you, of course, need to have a plan in order to remediate it. What this means is generate a new secret, find a solution where the secret can actually be stored. There are a lot of solutions out there, either HashiCorp Vault, if you use a cloud provider. The cloud providers, of course, have all their own solutions. Or if you're on GitHub, you can simply use GitHub secrets in order to store the secrets properly. And then, of course, you need to revoke the secret that was exposed. Okay, then let's come to static application security testing. So just to group a few things properly and the terminology. So there's always linting. So linting is really to check the quality of your code in terms of code smells. And SonarQube is the usual tool of choice for this. I know it has some security rules, but it's not really a security tool in that regard, because this would be tools that have only security rules and are really designed for it. And SonarQube has a lot of rules available and a few security rules, but I wouldn't really consider it as a SaaS tool, therefore. So for static testing, this means the tool is focusing on security vulnerabilities in the code. There are a few open source tools available. SemGrab is a quite famous one in recent years. MobSF is another one that is specifically for mobile apps, for binaries, and also for source code. Then we have SCA, meaning scanning of third-party libraries, and dynamic testing. Dynamic testing is a bit complicated for mobile apps. The only company that I know that is doing it for iOS and Android and properly is NowSecure, and this is a really nice way and a great integration also into a pipeline that they offer. Okay, so what we will be exploring again as a GitHub action is MobSF scan. MobSF scan you can install via pip on your machine, or also make it available as GitHub action in the GitHub action pipeline. Also, MobSF scan has the possibility to export it as SARIF, meaning it can be directly ingested into your GitHub also. So again, let me quickly show you this. Where are we? Where's my mouse? Okay, let me also do this here. Okay. So if we go back to our code and to our workflows, if I go now to MobSF scan, let's make it this time. Just edit this one. And so it's the same thing, just this time we are activating the GitHub action for MobSF scan. We're committing the changes. And this will now again, because we're doing now a commit, it will trigger now all the GitHub actions. So now we have 3 GitHub actions. I had an existing one, and the Git leaks we were just adding, and now we were adding MobSF scan. So now it should be 3 running. Yes, you can see here it's 3. So we go to mobsf scan, and now it's scanning the source code for different patterns that might be security vulnerabilities in your Swift code. So we can click on this. Then you can see that this job is now running at the moment. It's scanning now the code. If you click on this, you can see all the different steps that are being executed at the moment. So at the moment, it's executing the scan itself. Once the scan is being done, the SARIF file is created, and it's uploading it directly into your GitHub repo. So everything is happening on this runner instance, this virtual machine where this GitHub action is being assigned to, and it's already done. So we go again to security, we go to the code scanning alerts, then we can even select the tool. So now we have only the results from mobsf, and again you can see these are now the vulnerabilities. So you can start triaging them, saying it's a false positive, create an issue out of it, or whatever you think as from a developer perspective what makes sense. The cool thing is if you declare it as a false positive, like for example if we do this, and then we simply say this is now a false positive, then it's gone. And if we scan again with the SARIF format, GitHub is smart enough to identify that this vulnerability was there in the past, and we already flagged it as false positive, so it will never pop up again, which is really powerful, and is what I could see in many enterprise tools also still an issue to do proper false positive analysis. So with GitHub and the SARIF file, it's really easy to do proper vulnerability management and to do proper triaging also. Okay. Then let's come to the last topic, which is now SCA, Software Composition Analysis. So basically, Software Composition Analysis is just a fancy AppSec term for scanning third-party libraries. So it's just about scanning everything that is third-party in your server-side code, in your mobile apps, your JavaScript that might be in your web application on the client side, and scanning this for known vulnerabilities. There are a lot of different tools out there. I will be focusing on an open source tool, one that is from OWASP also, called Dependency Check. It's already out there for quite a long time, and it's mainly used for Java. But recently they were also introducing checks for package managers for iOS. For example, the Swift package manager and Cocoa Pods. This is both also supported, so you can scan these kind of libraries also on the iOS side. So let me show you this now. Where are we? So we're activating now the dependency check. So this is again a GitHub action. So I'm just uncommenting everything. And what this GitHub action does is it's triggering this dependency check against my repo. Once the scan is being done, it creates the SARIF file. It takes the SARIF file and is just pushing it again into the security tab or into the code scanning alerts from my repo. So if we go to the actions, you can see that now we have 4 different checks running. So they're all simply running in parallel. And we are, which one is the right one? Here's dependency check. So this one here is now running. So it's setting up the job. These GitHub actions, they can either be a Docker container. So this means when you're triggering this GitHub action, a Docker container is simply being pulled. Then the repo is being checked out into this Docker container, and then it's being scanned. The SARIF file is created and uploaded into your GitHub repo. And this is usually being done also pretty fast, as you can see. Obviously, if the code base is bigger, it might take a bit longer. But in general, it's a quite efficient way of scanning. So now we have this. Now we have, again, more alerts. Now we can select, where are we here? Dependency check. And we can see that there's 7 known vulnerabilities in the libraries that are being used in this iOS app that is here in my repo. So again, a really nice way of how we can scan for SCA now also. Yep. Okay, so now we have identified the vulnerabilities, meaning the libraries. The thing is just for SCA, it's always a bit complicated with libraries, because now we need to know how we can fix these libraries, of course. The thing is also, one thing to mention is that for SCA, there are no false positives, because we definitely have false positives when doing source code scanning and also when doing secret scanning. But for SCA, there are no false positives, because if the library was identified and there's a vulnerability in this library, it's definitely there. The question might just only be, is your source code calling the vulnerable function in the library? So yes, that might be a differentiator in terms of the risk, but at the end of the day, you would need to fix it. Usually the best approach is to go to the nearest version of your library. So if we say that we have a library version 2.4.5 and 2.4.6 and 3.0.1 are fixed versions, then it's usually the easiest to simply go to 2.4.6, because most likely there will be quite a few significant changes in a major version like 3.0.0, and then you might need to refactor the code, of course. So that's usually the best practice to do these kind of upgrades. If it's not possible to do an update, maybe the library is being orphaned and nobody has looked into it for years because it was some open source library, which unfortunately happens quite often, then you might want to consider to change the library. Sometimes the library was just something that was being used in the past and maybe it's not needed anymore. Then it can simply be removed, or you simply accept the risk, meaning the security team is accepting the risk if it's not significant. The thing is, with dependency check and with what we could just see in GitHub, it's of course great because it can give us the concrete vulnerabilities and we are also able to manage it, but it cannot really give us now the information about which library we should be using that has no vulnerabilities. And then it can become super tedious, because there are so many different libraries usually out there, so many different versions, and doing this task manually is usually quite troublesome and quite tedious. So this is where enterprise tools come into the picture. I mean, I'm not endorsing any of those, it's just alphabetical order and some of the things that I know. There's Black Duck, there's Sneak, there is Sonatype Nexus IQ. They have at least support also for mobile applications. And once you scan something, some of them have even an IDE plugin where you can fix the dependencies on the spot. So just by pressing a button onto the next version that has no vulnerabilities, it's doing everything on the fly for you. And it is really a good way of solving then your problem. You might have heard around DependerBot. So this is, again, something that is scanning for vulnerable libraries in GitHub. It's offered by GitHub. It's part of the GitHub environment. They have not really support for iOS at the moment, so this seems to be work in progress, so just for your information. The really cool thing, especially when you're then using an enterprise product, also Dependency Tracker, I think it's called, another open source project that is part of Dependency Checker, is that when you're scanning for vulnerabilities, you're automatically creating an inventory of all the libraries. And this is the real good and effective part, because in the future, when there might be another doomsday happening because of some remote command execution in some library, then if you have an inventory and you can specifically say this library is being used by this 10 applications, you can just immediately tell them, please update your libraries. Because in the past, of course, everybody was just running around like headless chicken because they have no idea where's this library now being used. And then you just start slowly to build up your inventory. So therefore, this is another benefit of doing SCA, because then you end up with a so-called SBOM, your software bill of material, that is clearly outlining what kind of libraries you're actually using. Okay, so to summarize what we discussed today, there are GitHub Actions. GitHub Actions are your friend. They can definitely help you a lot. So if you are already on GitHub and are using repos in GitHub, then GitHub Actions is definitely something that you want to look into. SARIF is a very powerful format, and it seems that more and more tools are using it, meaning you will have a quite powerful way of integrating it into your repository and into the secret tab and the code scanning alerts in GitHub. This is just a snippet of how you can upload then actually the file. So this is the actual power of the Git leaks action that I showed you, because this will upload the SARIF file that was being generated by the tool into the CodeQL and into the security, into the vulnerability section of your GitHub repo. And of course, all the scanning, SCA, SAST, and secret scanning should of course become an integral part of your development pipeline or your CI/CD pipeline. One last thing, there are of course many other open source tools, regardless if they're not open source or enterprise tools, but maybe just a few tips of what you might want to look out for, at least things that I could experience that not everybody offers, is to have this kind of deduplication of findings, because you do not want to end up with 10 times the same findings because you're scanning 10 times. You should have a way to easily flag out false positives and get rid of them permanently so that they're not showing up again when you're scanning again, and to customize the scanning with rules. So with Git leaks, you have a quite nice way of customizing everything. You can put in your own regular expressions to identify any API token that you might be using. And at the end of the day, scanning for findings or scanning for issues is one thing, but it's also very important that you can manage all the vulnerabilities. Because if you can only scan and cannot manage properly, then it's of course very troublesome in order to really make sense of all the output that you're having or that the tools are generating. Okay, and then we're at the end of the talk. I still have some stickers here also in front if you need more stickers from the OWASP MSTG project. If you're interested in the slides, you can also scan this QR code. And otherwise, thank you for your attention.
Thank you very much, Sven. Do we have any questions in the room? We've got time for maybe one or two, and we have one online if there's none in the room. None in the room? All right, so one online question. How do we guarantee the security of the key store files that we need to upload to cloud build servers, such as Bitrise, CodeMagic, etc., to build release APKs? Is there any security certified list of CI/CD tools?
I cannot think of anything that is not certified, but at the end of the day, as long as the secret is stored in something that is considered secure, like HashiCorp Vault, or anything that is part of the cloud provider, for example, and only the few specific people that should have access to it according to least privilege, then it makes the most sense. Otherwise, there is the way of, for example, Google Play Store, where the key is managed within Google already, and then they are signing it for you, so meaning you're giving the responsibility to them. So either you simply use proper key management solutions like HashiCorp Vault, or if the company is comfortable with this and is not violating any policies, then the key can, of course, be hosted within the SaaS provider also. I hope that answers the question.
Awesome. Thank you very much.